Welcome to Accelerated Engineering. My name is John, and today I'm doing a bit of a function showcase, I suppose. So I've seen a large number of questions on Quora about the problem of showing some combinatoric permutations. And what do I mean by that? The question has often been, what is the Excel function that allows you to show all of the permutations of a particular set of numbers? So there isn't a function in Excel that does that, so I went and wrote one. See, the custom function here that I've written is permute show, and then it accepts a number of inputs. So for example, with this output, I can take a number, well, I can take a couple of inputs and spit out all of the permutations of a set that is arranged that way. So what is all of this noise going on here? Well, I've got a couple of, I'm just going to color code this workspace really quickly. First of all, this is just some descriptive text. This is the interesting bit right here. These are my inputs. I'll just label my inputs in green. And what this is in this combinatoric function, n represents the number of sides that your dice have, basically. So for example, 2 would be a two-sided dice or a coin. You can imagine that this is flipping a coin r times. If I have n sides on a die and I flip it or roll it r times, that's the kind of situation that we're working with. And then npr, or npermute r, is a combinatorics function, and in Excel, the permutation a function will tell you how many different permutations there are for the number of sides of your dice, basically rolled however many times you want. And this is a checking portion to make sure that I get the right numbers, and this one just counts the number of outputs of my function. So this is a checking thing. This is just text, which is now goofily colored. Let's do it that way. I also have a mapping input array so that I can output a variety of numbers. For example, if instead of A and B, I wanted to use heads and tails, then my function would output heads and tails instead. Okay, so what's going on here? How do we solve this problem? I've got a rather large and complicated lambda function here, which is somewhat unnecessary. I'm going to break this down into smaller pieces so that it's manageable. Let's look at it. First of all, we can see that this is all nested within one large if statement. And what it does is it takes this first half and says, if there is no map array, basically if this HT 1, 2, 3, 4, ABCD, if that's empty, then all it will do is output sort of a zero based. It'll use the digits 0 through 9, and then A through Z. So the maximum number of things you can do is like 36. If there is a map array selected, then the function is a little bit more complicated. There's some extra math that happens, but this is just a selector between whether or not there is a function or a set of values to map that I want output, or if I just want the numbers 0 through 4. And I'll just demonstrate that really quickly. If this is empty, then it just outputs using 0, 1, 0, 1 in this case. If there are 4 values, it uses the values 0 through 3, and I'm just going to have this pick 1. If there are up to 36 values, then it outputs alphanumeric 0 through 9 and A through Z, and if I hit the 37, then it breaks. But that's, everything has limits. Okay. So the first half of this function deals with if there is no input array. So see, the first thing that it does, just expand this a little bit, I've broken out the code in order to make this more readable. The first thing that it does is calculates the number of permutations with repeats that are actually available in this number set. And we can see that this matches this check value here, or this matches the function of this check value, and that's all that that's doing. It's telling me how many permutations I actually have. The next part is the count up array. It is just a sequence that is intended to count up to 16 values. So it starts at 0, it is 0 based, and then counts up to 15, which gives you 16 values, 1 through 15 and 0. The output, in this case, is just a conversion of base. So it takes every value in this count up array and converts it into the base of the number of sides that your dice have, and it always pads it to make sure that you always get the correct number of values output. So for example, if that's if that value is ignored, then it just outputs, well, it outputs without the leading zeros. But we need those leading zeros. They're an important part of the function. And that's it. That's the output there. It gives me my basically counting in an alternative base. So that's the less interesting part. I'm just going to unhide this and hide that. Here we go. The second half is throwing reference errors because I haven't given it an input array. So I just need to provide an input array really quickly. I'll use hstack with the values A, B, C, and D. And it only uses values A and B because I only have n equal to 2 in this case. That makes sense. The first part of this function is the value array. And remember that this is all nested within the second half of my big lambda function. So what value array does is it calls this make array function, and it raises the base to the power of the number chosen. Pardon me. It says I need a number of rows that is equal to n raised to the power of r. That's the number of permutations. It solves that permutation A equation. I could probably actually do it that way instead. Because I need a number of columns equal to the number of things chosen, or the number of rows. And then it applies to that a mid and a base calculation. So the base calculation calculates the actual value, and then mid pulls the correct number out of that value. And the reason that it does that based on column is so that it generates that counting value broken apart into an array. So for example, if I was looking at this in binary, just this row, 0, 0 is equal to 0. 0, 1 is equal to 1. 1, 0 in binary, or base 2, is equal to 2. And 1, 1 is equal to 3. And if I change that to a different base, let's go base 16 because it's interesting, and scroll down far enough and see, oh yeah, here's 10, 11, 12, all in base 16. So that is all interesting, and that's what the value array does. If I pick, I only have space for up to 4 things in this particular case, but if I pick up to 4, it expands to fill all 4 columns. What the mapped array does, so this line of the function here, is it just takes the it takes my map array A, B, C, D, and takes in all cases the value in the value array plus 1. Because Excel is 1 based instead of 0 based, I have to add 1 in order to get that function to work. What it does is it says here, for this value, take the first value in the index, which is A. Take the first value in the index, which is A. Take the first value, A. Take the second value, B. And so on and so forth. It just takes that value array and maps it to the letters that I wanted. And then finally, the output column just smashes them together. It says for each row in this mapped array, take that input row and join all of the text together within that row. And then you get a nice spit, like you get your output spit out. And so basically that's it. With those two conditions and a little bit of an error check, it just checks for if the mapping array is omitted or if the mapping array is less than the number of things. So for example, if my map array is 4, but my number of sides of dice is 6, then it just sticks to the 0-based index. That's fine. That's it. That's how this function works. Now there is a limit to it, and the limit is that the maximum values that I've found is 2 and 20. So I can do n equals 2, and I won't type it in, but you can pick up to 20 things. And the reason that seems to be the limit is that is the number of rows that Excel holds in memory. So the value of that, I'm just going to calculate it over here, permutation A, for 2 and 20 is that 1,048,576. And if I scroll all the way down to the bottom of this sheet, 1,448,576. So after that point, the function there is no space to output. There isn't enough space in Excel. Also, performing that calculation uses, on my computer, about 5 gigabytes of RAM memory. It's a little bit memory intensive, so use at your own risk. Anything that produces a value larger, or a number of values larger than this, is going to break the function, and you'll have to figure out what the limits of your particular machine is. But that's the permute, or the function that I've called permute A show. That's its variety of inputs. If you want to use this function, there should be a link in the description of this video, which will link to a worksheet, and you can copy a tab. If I just do a new tab here, if you copy a tab of this worksheet that will be provided, then it will give you access to the permutation A, pardon me, that's completely the wrong thing, the permute A show. I have a couple other functions on the go right now. Permute show, and you can just enter your arguments. I have n equals 4, r equals 2, and I'll skip the map array for now. And this function will just work. You will just have it. If you do download the spreadsheet provided, please take a moment to at least subscribe if you want to see more content like this. I put a lot of time and effort, and I'd appreciate seeing the results of that. And that concludes the video and the explanation of the permute A show function, which gives all kinds of fun outputs and displays all of the permutations with repeats of arbitrary numbers and rolls. Hope that you're having a great day. Happy excelling.